We will now look at an application of finding a confidence interval for a single proportion where we're using the central limit theorem normal-based inference. If n times p hat and n times 1 minus p hat are at least 10, we are okay to use the normal, in which case we use this interval form here. So we take our sample value, p hat, plus or minus a normal critical value, times the standard error, which is the square root of p hat times 1 minus p hat over n. So when using this interval, if you should first check to make sure these conditions hold. If they don't, you could go back to the stuff we did with bootstrapping in chapter 3. So we have in 6.1.5 that we want to estimate the proportion of students that are left-handed so we could purchase new desks for a building renovation. There's a sample of 300 students and 32 of them in the sample are left-handed. So first of all, our sample proportion is 32 people out of 300. As a decimal value, that's a little over 10%, so 0.1067. Our conditions n p hat and n times 1 minus p hat being at least 10 should be checked. When you multiply p hat back by n, what you're going to get back is the count of how many you had, so 32. And when you take n times 1 minus p hat, what you're going to have there is the count of how many you didn't have. So if we have 32 out of 300 people who are left-handed, this would be who are not left-handed in that sample. So 300 minus the 32, which would be equal to 268. This is greater than or equal to 10, so check. This is greater than or equal to 10, and so check. So we can use the normal-based inference the central limit theorem holds. So to get our confidence interval, using this formula up here, it says we will do 0.1067 plus or minus our z. 95%, if you go in StatKey and look up that z, you'll get this 1.96 times the square root of 0.1067 times 1 minus 0.1067, which are our p hats in there, divided by 300. So what this is going to give us is 0.1067 plus or minus 0.0349. This number is still called our margin of error. When we add and subtract that, then we get 0.0718 to 0.1416. So this is our 95% confidence interval for P, the population proportion of students who are left-handed. On the next page, we are asked then to interpret that and then also asked about a specific value. So if we were going to interpret that exact interval, we would say something like we are 95%, you could say sure or confident that the population proportion of left-handed students is between, and then we could list our values, 0.0718 and 0.1416. So that interval is likely to contain the population value P. The Vice Chancellor decides 15% of the desks that the order should be left-handed. Is that an adequate proportion? Notice that the value 0.15 or 15% is not in the confidence interval. So that would probably be too high of a value, and they should order fewer. So too high, order fewer desks.